Hello and welcome to my short lecture on the subject Smart Cities and Communities. Now we will be discussing module number 3 on unit number 3. The topic is how to conceptualize the smart urban transportation system. So in order to talk about how the smart urban transportation system is evolving, we need to discuss first what are the three key drivers that are leading to the pushover for the smart urbanization regarding mobility. The first driver is urbanization. In order to earn the livelihood, more people from villages are coming and settling in the cities, and this will lead to congestion in the traffic, and in turn the users may find the transport experience poor. The next key driver that leads to this pushover is digitalization, the advent of ICTs, etc. The third key driver is climate change and resource efficiency. Approximately 15 to 20% of the emissions comes from urban transportation. So there is a strong push to make these systems more efficient and smart. Next, we need to discuss what are the two elements in this paradigm shift. The two paradigms are ownership to usership and separate transportation system to mobility system. Rather than owning a car, if you are using the vehicle you want to use, that is advantageous rather than having a own transportation system. If you are trying to use different kinds of transportation mode, you will be carrying less, and this will lead to some sort of mobility devices, that is multimodal transportation system. Digitalization. The use of ICTs in the transportation system may help improving urban transportation systems in terms of user experience and safety. ICTs can also monitor urban transportation infrastructure, and they can also be used to create automated driving vehicles. Now, there are three layers in the transportation system. First one is infrastructure, the next one is data, and the other one is service layer. Now when it comes to infrastructure layer, if you want to have ICT, you want to equip the transportation infrastructure layer with the data gathering devices such as video cameras, speed cameras, sensors for traffic detection like IR, laser, RFID, as well as wired and wireless communication. So because of this, there might be some direct implications in the infra layer. Now the managers have to pay attention to the interaction of this legacy transportation infrastructure to the new data infrastructure. Next comes the implications in the data layer. Actually, the data is collected from different channels, and they are to be used for ICTs, and the implications may occur in the reliability. We have to check whether the data is complete or incomplete, holistic or not. Then the data is gathered from different channels, and it may of different format. So the first thing that you have to do is you have to do standardization. Then the more important implication is data security. Once the data is gathered, you will be able to obtain accessibility and adequacy, quick response and safety. Then comes the service layer. Instead of making the manual driven cars, if you are going for machinization, that is, if you are transiting human driven cars into self-driving cars, then you need to have some automation with the help of data like traction, stability, brake status, mileage, hours of travel, etc. And this data will be collected using ICTs. Now, when it comes to automation, when it comes to self-driving cars, there are different levels of driving assistance or automation ranging from 0 to 4. Now, level 0 means it's completely relying on the human being who is going to drive, so no driver assistance. Level 1 means one driving assistance can be provided to the human being, like braking. Level 2 means driver benefits through driving assistance, for example, cruise control and braking assistance. Level 3 is conditional automation. The vehicle will be automated only under cases where human intervention is appropriate. At that time, the manual factor will be used. Level 4, completely high level automation with no human intervention at all. And in order to achieve all these, in order to achieve this automation, we need to go for V2V communication, V2X communication, etc. And the vehicles are to be provided with data processing and communication technologies to achieve this. And these vehicles are to communicate with road signs, traffic lights, speed limitations, road conditions, etc. And this will lead to implications in the service layer. For example, suppose in case if accident happens, then who is to be blamed? That becomes the question. Whether the driver is to be blamed or the automation is to be blamed. Who is to be blamed? That becomes the question. So these are the factors that you have to consider when you are trying to conceptualize the traditional transportation systems to the smart urban transportation systems. With this, we will close the session.